Hello everyone, welcome to the Easy Physics. In this video we are going to learn images formed by concave and convex mirrors. In the previous lesson we learned ray diagrams, and now we are going to use these ray diagrams to locate the images of objects. We have our mirror, principal axis, focal point, and center. Here is the center, here is the focal point. We can either put the object between the mirror and the focal point, or we can place our object at the focal point, or we can put it between center and focal point, or it can be at the center, or it can be somewhere here between center and infinity, or it may be located to the infinity. Okay, so depending on different locations of the object, where will be the image and its properties. Now we are going to learn all of them by drawing the location and the properties of the image. Let's start with the case when the image is at the infinity. When the image is at the infinity, parallel light rays are going to come to the mirror. Why? Because at the infinity they are going to move as parallel, and these parallel light rays will reflect from the mirror, and all of them are going to reflect from the focal point, and then the image is going to be formed at the focal point. Okay, next let's put our object between infinity and the center. Where will be the image? The object is at this point. In this case, let's draw some rays from the object to the mirror, and then let's reflect them from the mirror. This parallel ray to the principal axis will reflect from the focal point, as you see. And then another light ray to the pole of the mirror will reflect with the same angle. And the two light rays are going to cross somewhere here. So these two light rays are emerging from the tip of the object, and after reflection from the mirror they intersect somewhere here. So this is our image. As you see, when the object is between infinity and the center, or behind the center, the image is inverted. It is formed between center and the focal point, and this is a real image. Why? Because the light rays themselves cross and make an image. And also the size of the image is smaller than the size of the object. Next, remember, we start at the infinity, and then now we are approaching to the center, and let's put our object at the center. Here is the object. So where will the image be? Again, let's draw some rays from the tip of the object to the mirror. It will reflect from the focal point. Another light ray to the pole of the mirror will reflect with the same angle, and it will a light ray to the center, to the pole, will reflect with the same angle. So as you see, two light rays reflecting from emerging from the same point of the object reflects from the mirror, they cross somewhere here. So this point, okay, will be the image of this point. So here is our image. If you draw this light rays, reflection of the light rays and themselves on a paper, scaled paper, we are going to see that the height of the image will be equal to the height of the object. This is the height of the image and this is the height of the object. So again, as you see, the real light rays are crossing, so this is a real image, and it is the same size as the object. The heights are equal to each other. It is inverted and it is at the center. So when you put an object at the center of the mirror, a concave mirror, we are going to get an image at the center and at the same size. Okay, next let's move toward the focal point. Next location is the next location of the image is the between center and the focal point. Again, let's draw two light rays, one parallel to the principal axis. It will reflect from the focal point. Another light ray to the pole of the mirror will reflect with the same angle, and then it will move like this. As you see, at this point the light rays crossed. So where is the image and its properties? The image is behind the center and it is inverted. The image is inverted. Here is our image, and bigger than the object, and it's a real object and it's behind the center. Okay, let's move our object to the focal point. When our object is at the focal point, I'm going to use ray diagrams to locate the image. Okay, let's use two rays, and one of them is parallel to the principal axis, will reflect from the focal point. Another one to the pole of the mirror will reflect with the same angle. As you see, the two light rays, reflected rays, are parallel to each other. They are not going to cross each other, so we say that the image is at the infinity. Okay, next let's move the object toward the mirror, and then now the new location is between the focal point and the mirror. So let's use two other light rays, one parallel to the principal axis. It will reflect from the focal point. Another one to the pole will reflect with the same angle. As you see, these two reflected rays are diverging from each other. But if you are an observer looking from here, you are going to see that these two light rays are appearing to come from some other points behind the mirror. Not the real light rays are crossing each other, intersecting each other at this point, but their extensions are crossing. That's why a new image is formed, and this kind of image is called virtual image. As you see in this case, when the object is between the focal point and the mirror, the image is behind the mirror and it is not inverted, it is erect, bigger than the object. and it is behind the mirror. So that's enough, I think, for the images formed by concave mirrors.